Hi guys, welcome to chapter 14. In this chapter we are going to talk about acids, we're going to talk about bases, and as the chapter title alludes, we're also going to talk about equilibrium within all of that. So this is probably the one unit for Chem 152 that builds on the last chapter. So we will see more ice tables, we will see more equilibrium problems, but just from the viewpoint of acids and bases. So here's just kind of a preview of what's to come. We are going to cover acids and bases, so just kind of introducing you to acids and bases, then talking about pH, pOH, some fairly easy calculations with that. And then we're going to get into talking about like strong acids versus weak acids, strong bases versus weak bases. The second half of the chapter, we're going to take it a little bit further. So we're going to talk about salts and their acid-base properties. We're going to talk about buffers. And then if we have time, we'll get to titrations. This video is really just going to be an introduction to acids and bases. Very straightforward, easy peasy. But we got to start somewhere. So here's where we'll start. So acids have some pretty distinct properties. So acids are known to have a sour taste. Please take my word for it. Don't go testing acids in the classroom. But for example, if you've had something like Sour Patch Kids, right? That sour flavor is a tartaric acid. If you've ever bitten into a lemon or a lime, you know, citric acid is very sour. So we have some familiarity with this. Acids are also known to dissolve many metals. So one of the tactics in industry to kind of purify different metals is to expose them to acid. So they will dissolve metal. And then acids are typically denoted with a red color. And one of the reasons is the litmus test, right? So there's blue litmus paper and there's red litmus paper. If you dip if you dip red litmus paper in an acid, it will remain red. If you dip a blue litmus paper into acid, it will turn that paper to a red color. So that's kind of why they're denoted with a red color. Bases tend to be bitter in taste. So again, we've got some familiarity with this. If you've had like coffee or really dark chocolate, it has kind of that bitter taste. So that's a compound called theobromine that's in that like caffeine molecule, and that portion of the molecule has kind of that bittery taste. Bases tend to be kind of slippery in feel, so a lot of our soaps are made with or basic in nature. So if you've ever had that like kind of slimy, slippery feel with a soap, that's likely caused by one of these bases. And then bases quite often are denoted with the color blue. So it's the same thing, back to the litmus test. So if you dip blue litmus paper into a base, it stays blue. If you dip a red piece of litmus paper into a base, it will turn that paper blue. So they're usually denoted with the color blue. So here are just some kind of common acids that we'll see throughout the chapter. My hope is that you don't memorize these, that we just continue to practice with them and you become comfortable with them. So kind of the poster child for acids is hydrochloric acid, HCl. We'll see poster child for weak acids is this acetic acid. So we'll see these two quite often. If you look at the names of all of these, they do have something in common. They have this kind of ic acid at the end. So when we go to name our acids, if it is an acid made with a halogen, so remember halogens are in 17 or 7A, so chlorine's an example, fluorine's an example. We would just take the name of that halogen and we would add ic acid. So base name of chlorine is chlor. We add ic acid to the end. base name of fluorine is fluor. We add ic acid to the end. And then if it is a halogen, we tend to put that hydro at the beginning. So hydro, base name, ic acid. For acids that are made with polyatomics that end in ate, so nitrate, sulfate, phosphate. So if it was a polyatomic that ended in ate, we would do, again, the ic acid. So nitrate, we say nitric acid. Carbonate is another one, carbonic acid. Phosphate, phosphoric acid. The other thing to note with all of these is that there is a hydrogen that is in the front. That's going to be really important as we start to talk about the definition of of acids, donating that hydrogen or getting rid of that hydrogen. So that's why you see that hydrogen is highlighted. And then the last type of naming that I'm going to talk about for acids is polyatomics that end in ite, so sulfite, nitrite. There's no examples over here, but instead of being nitric, if it was nitrite, this would be nitrous. We'd put OUS acid. So that's kind of our way of delineating between the two. So here's probably, I would say, maybe the four most commonly used acids. Again, not something I want you to memorize, but just something that as we visit with and do problems, you'll get to know these. All right, so our discussion with bases. So common occurrence for bases is that we will have a group 1 or a group 2 metal attached to hydroxide. So OH is hydroxide. So if we put sodium, which is in group 1, sodium hydroxide. We could put magnesium, which is from group 2, have magnesium hydroxide. So the naming of those guys is exactly the same as you would for just a regular polyatomic ion. We use the name of the metal and then the polyatomic. Other bases that maybe aren't as obvious, again, these two just are the same, but we use the name of the metal and the polyatomic. Probably the one famous base that doesn't kind of fit the standard naming is this guy, NH3. Very commonly used base, but it's ammonia, NH3. So that's your introduction to acids and bases, just kind of getting to know them, seeing them, getting comfortable with them. We're going to talk much more about how I know those are acids and how I know these are bases in the coming videos. I hope you guys found this helpful.